Python counting number of presence and absence of substrings in list of sequences. You can get the data here. 2 shared the bottom download. I'm analyzing biological data with Python. I've written down a code to find matching substrings within a list of lists of long strings. The substrings are in a list and have length of 7 nucleotides. So in the list, from RRR to TTTTTTT, 16,384 motif substrings are present, permutating A, C, G, T. This code has A for loop for the list of substrings and the list of lists of long strings nested inside. It works okay, but because of the list of lists with 12000 lines, the code processes very slowly. In other words, to give info about RR and to the next which is RUC takes 2 minutes. So it will take 16,384 motifs to go through 12,000 lines for 2 minutes. It will take 16,384 times 2 equals 32,768 minutes, 546 hours, 22 days. I'm using scipy and numpy to get values. What I want to is counting number of presence and absence of substrings in list of sequences. The list of long strings and the code are like this. Is there any easier method, without implementing any other things? I think the iteration for pattern match is the problem. What I'm trying to find is both how many times a length 7 motif occurs in the whole list of sequences and not occurs also. So if a motif is present in a string, which is true as bool, then increment a value and false, then increment another value. Not the number of motifs within a string.
The problem was Fisher's exact test mounting, I guess. If I take the calculation for p-values outside of for loop, then the calculation becomes much faster.
Excellent question. This is a classic computer science problem. Yes, there is indeed a better algorithm. Yours processes each long string 16,384 times. A better way is to process each long string only once. Rather than searching for each motif within each long string, instead you should just record which motifs appear in each long string. For example, if you were searching for length 2 motifs in the following string, then you could run a loop over the length 2 substrings and record which ones are present in the dict. Now you've processed the entire string exactly once and found all the motifs present in it. In this case, the resulting dict would look like. Doing something similar for your case should cut down your runtime by exactly 16,384-fold.
A clean and very fast way, tilde15s with ops data, would be to use the count vectorizer of scikit-learn as it uses numpy under the hood, for example. Now X is a sparse matrix having all possible chunks as columns and sequence as rows, where every value is the number of occurrences of the given chunk in each sequence. Now you can sum along the columns, mask non-values or whatever manipulation you need to do, for example. Finally, to find how many occurrences a given motif has, you must find the index of the corresponding motif/chunk and then evaluate in the previous sum. In your case, you would have to divide your list in two parts, positive and negative values, in order to include the down condition. I made a quick test with the list from DSM's answer, and it takes around 3 to 4 seconds in my computer to run. If I use 12000 length 4000 sequences, then it takes a little less than a minute. Edit: the whole code using ops data can be found here.
There are several odd things about your code. What you're calling permutations looks more like the Cartesian product, which can be computed using itertools.product. Because Python is zero-indexed, the first element of a string is at index 0, and so the comparison like I2.finds motif, 1 will return true if the string is there right at the start, which seems a little odd. Your odds ratio, value and enrichment calculations are inside the loop, but neither the zeroing of the counts nor the print is, which means you're computing them cumulatively for each new row but not doing anything with that information. You recompute I2.finds motif multiple times in the typical case. That result isn't cached. Assuming that I understand the numbers you're trying to compute, and I could well be wrong because there are several things you're doing that I don't understand, I'd flip the logic. Instead of looping over each motif and trying to count it in each row, loop over each row and see what's there. That will be roughly 7 the number of rows instead of the number of motifs the number of rows. For example, I lowered the line length just to make the output faster. If the line is 10 times longer, the code takes 10 times as long. This produces on my slow laptop, after inserting some line breaks. So I'd figure about 20 minutes for the full problem, which isn't bad for so little code. We could speed up the motifs _not_ scene part by doing the arithmetic instead, but that'd only get us a factor of 2 anyway. On a much smaller case, where it's easier to see the output,